Hello, welcome back to Learn Physics. In today's topic, we are discussing with the previous year question paper. So in last video, we did tell our 14th question. Today I am starting with the 15th question of the same question paper. Okay, 2018 question paper only. Okay, so 15th question. Show using a proper diagram how unpolarized light can be linearly polarized by reflection from a transparent glass surface. So here unpolarized light after reflection, it should get polarized. So how it will be happening? The refracted ray and the reflected ray, between those two rays, the angle should be 90 degree. Remembering, right? Using that only we derived the Brewster's angle and all. Okay, so here this is transparent glass plate. So light ray is incidenting. It is unpolarized light. This is the representation of unpolarized light. So when it is coming here, this is the normal. It will be getting reflected and it will be getting the refracted also. Rarer to denser medium towards the normal. So reflected light ray and the refracted light ray should be of an angle 90 degree. So this is unpolarized light, but the reflected light ray will be of polarized light. Okay, so if these two are at an angle 90 degree, we will be getting an angle of reflected ray will be of polarized light. Okay, this is how you should mark. Okay, clear? Next is the figure shows a ray of light falling normally on the face AB of an equilateral glass prism having refractive index 3/2 placed in water of refractive index 4/3. Will this ray suffer total internal reflection on striking the face AC? Justify your answer. So this one, a diagram is given here. This is B part. So the diagram is, this was A part and the diagram is given like this. Okay, A, B, C, ray of light is incidenting here. Okay, so the ray of light is falling normally on the face AB and it is an equilateral prism. So this is 60 degree prism. Okay, so having a refractive index of 3/2. Refractive index of glass prism is 3/2 and placed in water of refractive index 4/3. So refractive index of water is given as 4/3. Will this ray suffer total internal reflection on striking the face AC? Justify your answer. So since it is falling normally here, it won't deviate, isn't it? It will be falling directly over here. Okay, after coming back, so how much will be this angle? We know this is 60 degree and this is normal. So here it will be 90 degree. If it is 90 degree, this will be 30 degree. If that is 30 degree, the rest of the things will be 60 degree. So angle of incidence is 60 degree. We should find out whether it will suffer total internal reflection or not. Okay, for that refractive index is given. Okay, so if the total internal reflection should happen means, what is the condition? Refractive index of the second medium with respect to the first medium will be equal to sin C. Okay, here we have, so what will be sin C here? N2 divided by N1. So what is N2 by N1? 3/2 divided by 4/3. So we will get it as 9/8. Okay, that is equal to sin C. So sin C we are getting it as 9/8. So here it is equal to 1.9/8 will be equal to 1.1 1.11 like that we will get. Okay, so here this is the value of sin C. Okay, then here next is here we are getting what is the refractive index over here, sin 60. Sin 60 is root 3 by 2. Okay, root 3. What is the value of root 3? 1.732 divided by 2. So we will get it as 0.866. We will get like this. So sin 60 is 0.866. But here we should get sin C as 1.11. Then only we will be getting a what is that? Total internal reflection will happen only if sin C is 1.111 or greater than that. Okay, here we are getting sin 60 as 0.866. So whether this total internal reflection will happen? No, total internal reflection won't happen. It will come out. Okay, it will be away from the normal. Okay, clear for you? So the next one is, if one of the two identical slits producing interference in Young's experiment is covered with glass, so that the light intensity passing through it is reduced to 50%. Find the ratio of the maximum and minimum intensity of the fringe in the interference pattern. So when the light is passing through, what is happening? Light intensity is reducing to 50%. So I2 by I1. If I am 60 into 1, I2 by I1, while I am considering how much I will be getting, 50. If I1 is 100, it became 50%. That is 1 by 2. Okay, so what we should find out here? We should find out the ratio of I max divided by I min. We should find out. So this is the ratio of I2 by I1 means what will be the ratio of A2 by A1? It is root, isn't it? 1 by root 2, because I is proportional to A square, isn't it? So here what is I maximum? I maximum will be equal to A1 plus A2 the whole square divided by I minimum is A1 minus A2 the whole square. Okay, so here we can write it as A1 equals root 2 A2. So here A1, instead of A1 we can write it as root 2 A2 plus A2 divided by root 2 A2 minus A2 the whole square. Okay, so A2 and all will get cancelled. So root 2 plus 1 divided by root 2 minus 1 the whole square. So this is the value of finding out this I1 by maximum, ratio of maximum and minimum intensity. What kind of fringes do you expect to observe if white light is used instead of monochromatic light? See, if instead of monochromatic light, white light, while we are using, what will happen? Chromatic aberration will happen. Isn't it? See, many intensities, light of many, the white color will be forming, violet, indigo, blue, green, yellow, orange, red. All the wavelengths are present. So what will happen? It will be forming different maxima positions. So intensity will be reduced over there. Okay, that is no clear fringes will be obtaining. Okay, that means, see, violet will be forming a number of patterns and indigo will be forming a number of patterns. So no clear fringes will be forming, and in between we can see central bright fringes for each wavelength and some fainted patterns on either side of each wavelength. Okay, so we know we should use a single wavelength for getting the interference pattern. Instead of that, if we are using a white light, it includes all the 7 colors. So no correct fringe pattern will be observing there. Okay, no correct fringe pattern will be observing there. For each wavelength, some fainted fringes will be observed. Okay, so no clear pattern will be observed in this case. Okay, so the next one is 17th one. A symmetric biconvex lens of radius of curvature r and made of glass of refractive index 1.5 is placed on a layer of liquid placed on top of a plane mirror as shown in the figure. An optical needle with its tip on the principal axis of the lens is moved along the axis until its real inverted image coincides with the needle itself. The distance of the needle from the lens is measured to be x. On removing the liquid layer and repeating the experiment, the distance is found to be y. Obtain the expression for the refractive index of the liquid in terms of x and y. So a liquid lens apparatus. So in terms of x and y, we should give an expression. Okay, so here diagram is given like this. See, this is plane surface and here a convex lens, and from here this is the needle. When liquid is present and liquid is not present. When liquid is present, the distance from the needle, it is focused. So we are getting the F1. So I am considering this as here a convex lens. If liquid is not there, we have a convex lens. A convex lens, and if while liquid is there, we will be getting a plano concave lens, isn't it? It will be like this. Okay, one convex lens and one plano concave lens. These two layers it will be. Okay, so here how we can find out if convex lens alone is there. The focal length is given as, what is that? On removing the liquid layer, focal length is y. So this one I am taking it as f1. And initially with the plano concave mirror, we are getting the focal length of, here this one we are getting f1 plus f2. Including both, I am getting the focal length of x. Okay, total focal length is given as x. So we know lens maker's formula, 1 by f equals n minus 1 into 1 by r1 minus 1 by r2. So here in this case, if I am considering 1 by f equals n minus 1. n minus 1 is the glass of refractive index 1.5 it is given. So 1.5 divided by 1 by r minus r. This and all you know, this side r means this side we will consider it as minus r. So we will get it as 0.5 into 1 by 2 by r we will get. 1 by r plus 1 by r, 2 by r. So we will get it as 1 by r. This is f1. 1 by f1 we got it like this. Okay, then next how we can find out for a plano concave lens. So here 1 by f1 plus 1 by f2 equals x. So 1 by x. Okay, 1 by f1 plus 1 by f2, you should write it as 1 by f1 plus 1 by f2 equals 1 by x. That is the formula, right? So here 1 by x equals 1 by f1 is 1 by r plus 1 by f2. f2 means this alone we should consider. So refractive index of 1 by f2 is n minus 1 of the liquid minus 1 into 1 by r1 is infinity, since it is plane. This is 1 by r2 is r. So this is refractive index of the radius is r. So here 1 by f1 we got it as 1 by y. 1 by x equals 1 by y plus nl minus 1 into minus 1 by r. So here we will get it as 1 by x, 1 by r. Instead of 1 by r we can give it as 1 by y. So equals 1 by y plus minus nl by y plus 1 by y. Okay, so here we will get it as 1 by x equals 2 by y minus nl by y. Okay, so here we will get nl by y equals 2 by y minus 1 by x. Okay, so this formula you can use it. This is the relation connecting NL equals 2 by y minus 1 by x. In this way we will get. Okay, clear? So this is how we will be finding out the equation. So this is a liquid lens. Actually this question is there in the additional exercise. Okay, so each and everything what we are understanding from this topic is thorough with your textbook. Okay, nothing else you should learn. Usually children will be handling 4-5 textbook, resource book, extra books. Better than that, first go along with your NCERT textbook thoroughly. Each and every line you should read thoroughly. Then you will get it. Okay, so the next one, 18th question. State Bohr's postulate to define stable orbits in hydrogen atom. How does de Broglie's hypothesis explain the stability of these orbits? See which one is explaining stable orbits. See in the second question a clue is there for that. How does de Broglie hypothesis explain the stability of these orbits? So stability of orbits, de Broglie's explanation is given only in the second postulates. So in that itself it has given an idea. Second postulate as the giving an idea to define stable orbits can be defined with the help of second postulate. Okay, Bohr's second postulate, what is that? Each and every orbit as the electron which is staying in each and every orbit will be of having angular momentum NL into h by 2 pi, isn't it? L into h by 2 pi. In that integral multiple of h by 2 pi, there only it will be having the orbits will be, the electrons will be existing only in such orbits which is having an angular momentum NL, that is NL into h by 2 pi. Okay, so that one we are proving with the help of both the de Broglie's hypothesis. Okay, so that proof also you should learn. Okay, here we will do now. So here in second postulate, MVR, angular momentum as an integral multiple of h by 2 pi. L is equal to MVR, that is equal to NH by 2 pi, isn't it? Lambda equals h by p. This is de Broglie's wave equation. Lambda equals, we can write it as h by mv. What is lambda? N lambda if I am considering NH by 2 pi. So what is lambda? NH by P, H by mv. N times the wavelength. What is that? N times the circular orbit. To get the, see, if the electron is revolving in the circular orbit, it will be a complete wave. So it won't come like this, it will be completing the wave. While you are drawing, you should draw it correctly. Okay, so like this it will be a complete wave. Okay, n times the wavelength we will say. So here we can write it as, so here n lambda we can write it as 2 pi into r, n times the wavelength. So that will be equal to 2 pi r into, that is NH by mv. So we can write it as mvr equals NH by 2 pi. So like this we will get, what is NVR? That is the angular momentum. Angular momentum equals NH by 2 pi. This will be helping to define stable orbits in hydrogen atom. So in that Bohr's postulate, second postulate, starting itself this the line is same like this one. Okay, the second postulate helps to define the stable orbits in hydrogen atom. Okay, so usually the orbits, stable orbits means usually children will be having the tendency to write down the first postulate. It will be moving in an particular energy orbit, isn't it? So but the stability is determined by this angular momentum expression, second postulate. Okay, so the next one is explain the process of nuclear fission and fusion by plotting a graph of binding energy per nucleon and mass number. Okay, binding energy per nucleon and mass number here, binding energy per nucleon is over here, and here we know that is 30 to 170. it is almost constant. Okay, so then it is energy is decreasing, isn't it? So nuclear fission means nuclear fission. Fission means small nuclei, bigger nuclei will be splitting up into smaller nuclei, isn't it? So this will be happening in the case of if the atomic number is greater than 200. Okay, so greater than after 170 only energy is decreasing. So while it is splitting into smaller nuclei between 30 and 170, what will happen? More amount of energy will be released. Okay, so nuclear fission will be happening usually which is greater than atomic number greater than not atomic number, mass number which is greater than 200. So greater than 200 energy is less. So it will be splitting it into nuclei which is having mass number between 30 and 170. So large amount of energy will be released. But in the case of nuclear fusion, what will happen? Smaller nuclei will be fusing together and converting it into bigger nuclei, isn't it? So smaller nuclei are here, and when it is converting to bigger nuclei, what will happen? The energy is decreased, also increasing. So a large amount of energy will be released over there. Next is radioactivity question. Radioactive isotope has a half-life of 10 years. How long will it take for the activity to reduce to 3.125%? So half-life, T-half is given as 10 years. And how long it will be taking time, it is asked to find out. It is reduced to 3.125%. It is reduced to 3.125% means 3125 divided by 100. Okay, 3.125 divided by 100. So we can write it as 3125 divided by 10. So while we are solving, we will get it as 1 by 32. So that is equal to 2 to the power 5. So n is 5. Half-life is 10 years. Okay, 1 by 2 to the power n, isn't it? So half-life is 10 years. So the total time required is 2 into n in 5 into 10, that is 50 years. Okay, clear? So this is how we will be doing the next one. So next is a student wants to use two PN junction diodes to convert alternating current into direct current. Two PN junction diodes are required to convert an alternating current into direct current. So what will be that one? Sender tapping. Two diodes we will be using, and we will be finding out the final equation. How? So transformer is here, and from here sender tapping we will be doing to get the continuous supply, isn't it? So this is how we will be finding out the sender tapping to get the output as the continuous supply. Okay, two diodes will be used. Sender tapping is continuous supply of AC. To get AC, we can use a normal the half wave rectifier also, full wave rectifier also. So here we should use the full wave rectifier. So give the truth table and circuit diagram for a NAND gate. NAND gate means AND with a NOT. So that is NAND gate. Okay, AND gate with a NOT gate is an AND gate means A, B, X. So how the truth table will be written? A 0 1 1 0 1 1 0 0. So 0 0 will be 0, and this will be 1. 1 1 will be in AND gate, it will is 1. So NAND gate it will be 0. Here it is in AND gate it will be 0. So it will be 1. 0 and 1 in AND gate it will be 0. So here it will be 1. Okay, this is how we will be writing the NAND gate. Okay, so these are the till 20th question we did. So 21 and section E. All those are what is that? Derivations only, so that also we will discuss in the next class. Okay, so from 21st question onwards we will be discussing the next class. Okay, so I hope it is useful for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.